In 1927, a German physicist named Werner Heisenberg theorized that it is not possible to measure the position and momentum of a particle simultaneously. This theory later came to be known as Heisenberg's Uncertainty Principle. Before we delve into the uncertainty principle, we need to understand what exactly the two main variables involved mean. The position refers to the physical location of a particle, where it is currently situated. Momentum is the amount of movement in a moving object. This is calculated by using the velocity, the rate of displacement, and the mass of an object. To understand the uncertainty principle, let's look at a real-world application. In order to locate the position of a particle, we need to be able to see it. The process of seeing requires light to reflect off the object back into our eyes. Light involves photon particles. So, if we wanted to look at a particle, for instance an electron, the photons would be required to reflect off the surface of the electron. However, whilst this may result in us being able to see the electron, we cannot calculate the momentum of it since it would have changed. This is the same situation that physicists face in the reverse situation, where we want to measure the momentum but cannot locate the position of a particle. The main reason behind this is due to the concept of the wave-particle duality. This means the particles have wave-like properties. The more intense the rise and fall of the waves are, the more imprecise the wavelengths are. The wavelengths represent the momentum. Therefore, we have the position, but not the precise momentum. Alternatively, the weaker the rise and the fall of the waves are, the more precise the wavelengths are. However, the position is imprecise. An interesting point to note is that this concept only applies to incredibly small objects. The product of the errors in the measurement of the variables, position and momentum must be equal to or greater than something known as the Planck's constant divided by 2 pi. Planck's constant is equal to approximately 6.2 multiplied by 10 to the power of negative 34 joules seconds and is incredibly important in quantum physics. This means that in practical applications, scientists must change their method of experimentation in order to account for the uncertainty principle. They can either find a precise measurement of momentum or the precise position of a particle. The Heisenberg Uncertainty Principle is quite complex, but it is also very intriguing. After all, as Werner Heisenberg once said, not only is the universe stranger than we think, it is stranger than we can think. This is The Scientific Mind with Ishtanetra Siva.